Okay, so all right, so we have studied, or we have been introduced to kinetic and potential energy. Okay, remember, kinetic energy is the energy due to motion, which is moving, and we discussed that the kinetic energy formula is 1/2 mv squared. Kinetic energy is in joule, mass is in kilogram, and velocity is meters per second. It cannot be kilometers. You have to convert. Anything else has to become as the following right there. Okay? Please remember that if you don't have the velocity into the problem, then you're going to have to look for it, right? Okay. Also, we have actually introduce you with potential energy. That's anything you lift up away from the ground. Okay? And we have introduced you that P, which stands for potential energy, okay? mgh, mass, gravity, and height. And that's the units right there. And it's also energy, so it is joule. Okay? But please remember that this formula is only applicable when you lift an object from Earth. Okay? Only applicable in this case. Okay? All right. Questions? No? Okay, so let's go ahead and turn the page to the back. Okay. We have a new set of lecture. Okay, so I'd like for us to go over. Okay. So before I do that, okay, let's spend a minute here for you to go over it, okay, to understand what's going on, so I can attack this pretty well, okay? So this is conservation of mechanical energy. This is a deep lecture, okay? So please read the first information by yourself right there, so I can go over all that. Make sure you highlight some information there to help you out, okay? Okay, so right now, remember this sign right there, which stands for change. Okay, this sign there represents change again between initial and final. So you have the change in kinetic energy. Okay, so if you have the change, you must have a final minus initial. So you have the change in kinetic energy is equal to kinetic energy final minus the kinetic energy initial. The final is 1/2 mv squared final, right? Because the kinetic energy is 1/2 mv squared. So right now you put the final up here. So you have a final up here. Okay, so this is your final right there. Okay, and this is your initial right there. Why is that? Because velocity must have initial and final. Okay, velocity must have an initial and a final. Okay. Okay. So right now we're looking at a formula which is a little bit more expanded. Okay, and we'll go from there later. So let's do an example. The example I provided to you there, okay, is a bowling ball in motion. That means it's moving. The mass is 10 kilograms. Okay, it has a velocity initial, and it also has a velocity final. Initial is 2, final is 3. This is before, this is after. Okay? We are asked to find the change in kinetic energy. You see this? So use the formula, which is 1/2 mv squared final minus 1/2 mv squared initial, right? Which is the change in the kinetic energy, right? Okay? It's the formula from above, right? Okay? Now, what is the mass? Well, it's 10. And it's applicable for both of them, right? It's 10. Okay? What is the velocity final? It's 3. And what is the velocity initial? It's 2. Right? You just go ahead and plug those in. So remember, final, initial. All this gives you 45. All this gives you 20. So 45 minus 20 gives you 25 joules. Okay? Any question based on that, people? Is that easy so far? Okay. If you had the information right there into the problem, it should not be that difficult, okay? Because you had to say initial, final, mass. There's not much to it, okay? So, the change in kinetic energy of an object in motion occurs either in the x-axis and or the y-axis. We discussed that today also, okay? Okay. Let's now turn over the paper, please. Okay. Now, let's look at a proof in physics. That's the fun stuff. Okay? All right. All right, let me go in detail. So put your eyes up there, and hopefully you're awake, okay? Let's prove that work is equal to the change in kinetic energy. Okay? The reason of this proof is that it will help us in the development of a new equation in the near future, okay? So the proof goes as the following that I wrote down for you, okay? Work is equal to change kinetic energy, where work is force times distance. We know that, right? We know that force is ma. And D must come from one of the kinematic equations. Okay, let's use one of those equations there, which is velocity square final, velocity initial square plus 2ax. And that's one you haven't seen much. It is there. Such that x is equal to d. Okay. Then we can rewrite this equation right there in form of distance. Okay. We divide both sides by 2a and subtract that. Okay. Now, observe that. Work is force times distance. Force times acceleration. The distance is the following that I just came up with there. Okay. Now, if I do the entire mathematics there, which I do not require for you to do, okay, I'm coming up with 1/2 mv squared final minus 1/2 mv squared initial, which is the kinetic energy final, minus kinetic energy initial. This represents the change in kinetic energy. So this concludes that the work must be equal to the change in kinetic energy. This, you only need to remember this right there. Okay? But I just want to show you that it is true. Okay? It's a valid statement that the work equal to the change in kinetic energy. People, I do not require for you to know this. But you need to understand that if you ask me, well, Mr. Becker, why do you say this is that and that? Well, I did show it to you a little bit, okay? That it is true, a true statement. Okay? All right. So if you go into deep physics, we ask you to do some proof here and there that it is a true statement, a true theory, things like that. But right now, you guys, the only thing you need to know is work equal to change in kinetic energy. All right.